Hi, I'm Pete, and welcome to Just a Few Acres Farm. I goofed up on my drainage project. See that water right there, about halfway up the pipe? It shouldn't be there. Here's what happened. I'm digging along, I'm digging the connector that goes all the way down to the outlet down there, and I'm digging along and I'm digging along, and I start to hit wetness. At the edge, right at this fence is really where it changed. I went away after I'd finished digging to come back and lay the pipe the next day, and that wetness turned into mud in the end of this trench. And when I laid the pipe, I couldn't measure the elevation exactly because the pipe was squishing into the mud and things. Well, it turns out the first probably 30 feet of that pipe out there was too high. It humped and then came down into here. So I didn't have positive flow. So I dug all this back up, starting at the vents here at the connectors, back probably 50 feet, shot the grades, found it where it was 6 inches lower than the vents, dug all this up, and then very, very carefully, and doing a lot of shovel work, laid new pipes in with a slope. And as soon as I did it, the water started running. But unfortunately, I screwed up in more ways than one, actually 3 ways. Here's the second way. I have another dip in the pipe right after these vents here. It comes down, and then it starts to gradually come up, and that's why that pipe is holding water that I showed you, that trench is holding water. So I'm starting all over again. I'm going to start right here at my vents and be very careful about digging the elevation up. Now the nice thing is that the pipes are draining, just not in this section where it holds water, so I'm not going to be digging through mud. I'm going to be digging a dry bottom, and I can measure the elevations accurately that way. So all this in the winter pasture is basically wasted work. I'm abandoning it. I'm going to fill in all the trenches, start new with the vent pipes, and not dig in the same spot, but dig alongside so I'm in compacted earth and not backfill, and just lay a new system in with about the same configuration, only with positive slope over the whole thing. Here's the third screw up. Let's get down in the trenches. This is what we have in the winter pasture. We've got a layer of really rich topsoil. After all, the cow's been pooping in here for years and years. But once you get below that, it's clay. See how it smears? This is a good test for clay. The other good test for clay is to do this. When I ball this soil up, it's a high clay percentage soil. No soil is completely one type, very few anyway, but this one has a vast majority of clay in it. So my drainage system wouldn't work very well. Problems 1 and 2, the height of the pipe or the depth of the pipe in the outlet trench and in the winter pasture, are pretty straightforward to fix. Unfortunately, I have my arm-mounted laser level sensor hack now to get the grades just right and know that I have no high spots. Problem number 3 takes a little bit of analysis. Problem number 3, of course, is clay soil. And the problem with clay soil doesn't drain worth a crap. It tends to act like a sponge and hold water. Water doesn't flow through it like it would other soils. Now, little did I know when I started this project that I had stumbled into one of what I would call a YouTube hotspot, where people debate back and forth a lot of different solutions for subdrainage. And fortunately, I am kind of equipped to deal with that sort of debate. I have a background in architecture. I was the principal at a firm for 20 years and have the education and worked with a lot of civil engineers and landscape architects on finding unique solutions to all kinds of drainage projects. First thing we need to know is about soil particle sizes. There's 3 main ones. There's clay, what I'm digging in, which is the finest, the smallest particle size. Then comes silt, which is larger particle size. Then comes sand, which is the largest particle size. Any soil is usually a mixture of these 3 in varying degrees, and I happen to be in one that has a predominance of clay. You have to know your soil to design a subdrain system that will work in that soil. There's no one-size-fits-all solution. And I'm going to cover clay soils here, but you'll get some knowledge about other types from what I'm doing with the clay soil that I have to deal with. Solutions have evolved through time. If I draw here a cross section, say this is a trench that I'm digging, the simplest method that's in use on farms all over the place is to just put a tile in that trench and then backfill the trench with the dirt you took out of it. There are thousands of miles of tile laid this way in the US, and it does not fill with soil, at least not immediately. Every construction system has a service life, and it takes long enough for these pipes to fill up gradually over time that it's worthwhile to dig them. Now, this is a low-risk application. The only thing at risk if this doesn't work is the field floods, or you get a little wet spot in the field. This is not a solution that's used around yards and foundation drains because there you're in a high-risk situation. If this thing doesn't work, you're standing to lose a lot of financial things that are worth money in the house over here if the basement's over here. So this system is not used in residential applications, and it's not really suitable for my application because of the clay. Now let's go to the next progression from the simple farm field tile line. Tons and tons of this installed with a service life not of months or a few years, but decades. That's what my pipe would have lasted, decades. My pipe suffers from other problems. No pun intended, or no double entendre intended. Anyway, this is the next iteration of that system. It's a pipe with filter fabric wrapped around it, a sock. You can buy these prefabricated sock. I'll show you what filter fabric looks like later on. You wrap a sock around the pipe to keep it from fining up, to keep the soil or the fines from building up in the pipe. This solution works fine in coarse grained soils like sand. If I've got sand out here, sand in my backfill, it flows fine into that pipe because it's like when you take, say, a quite large rock and push it against a piece of hardware cloth. If we were to blow up the whole example, water will still flow around those rocks into that hardware cloth because the rocks don't fit tightly together. They got crevices in between them. If you move upwards to silt, you get finer particles, so the filter doesn't flow as well. If you move to clay, that fabric will clog up relatively quickly because those particles seat tight together on that membrane face, and then it doesn't work. Nothing gets into your pipe. Your pipe doesn't clog up, but nothing gets into it. It's sealed. The example is a coffee filter in an electric drip coffee machine. If you pour sand into that filter, pour water over the sand, the water's going to go right through the sand, through the filter, and you're fine. If you put silt, or to use our example, coffee, a finely ground coffee, into that filter, the filter behaves as it's supposed to. It keeps the coffee grounds out of the coffee, but the water slows down because the particle size of the grind is approaching the particle size of the filter, but the filter doesn't clog up with fine particles. It still flows. If you were to take the clay that I was balling up out there in the trench, smear that over the coffee filter, you wouldn't get any flow through that coffee filter. That's the same example as the fabric wrapped pipe. And that's why people line ponds with clay in coarse-grained soils, freely draining soils, because clay can become a waterproofing material. You don't want it right around the pipe stuck to a sock. So this solution won't work in my situation. Now, there are variants on this solution. You can put gravel in here, screened gravel or washed gravel, a clean material, and slow the amount of silt or clay that's getting onto this filter fabric. But ultimately the problem is the barrier here. This is going to silt up eventually over time, and you're going to wind up with a clog. A third solution, and this one was popular when I left architecture 10 years ago, and it's called a burrito. The first thing you do after you dig the trench is you lay filter fabric in the trench like this. You line the whole trench with it. You put some stone in the bottom, a couple inches or so. You lay your drainage tile. and then you put the stone around and over the tile pipe. And then when you're all done, you take these ears of the filter fabric and you fold them over, and that's why it's called the burrito, because you've made a burrito filled with stone in the drainage pipe. And the thought was you've increased the surface area of the filter fabric enough to prolong or keep it from clogging like this small surface area would. So as water flows through the clay and picks up fine particles, you have a large area around this for those particles to get trapped against. It works better than the previous solution, but I learned, because I went back and studied this stuff, I've been out of the game for 10 years now, that this solution has really fallen out of favor in clay soils. And so I had to scratch my head a little bit. I looked around a lot, read a lot of materials, looked at some YouTube videos, and realized that there's a lot of debate over what's appropriate in clay. So I had to come up with my own system understanding how clay behaves. And it's this. This is what I'm going to be putting in. I'm going to dig my trench. I'm going to leave the bottom of that trench virgin material. And I'll get to that in a minute. I'm going to put a couple inches of stone in the bottom of that trench. I'm going to set my pipe on the stone. I'm going to put stone over and around that pipe, continue filling the trench with screened stone that doesn't have fines in it. And then I'm going to take a 2-foot wide piece of filter fabric and I'm going to lay it over that. I'm not going to wrap it around. I'm not going to wrap it up here. And then I'm going to backfill with what I took out of the trench. That clay soil, however you want to represent it. I'll use dots. Given the choice between burying a bare pipe in my original farm field drain solution and doing a burrito, I'd rather do the bare pipe, because the bare pipe will silt in very slowly, especially given the nature of clay, which is to be cohesive. The trench walls smear, they don't crumble. Actually, what will happen after the backfill reconsolidates as clay is, as the soil moistens, it'll expand around that pipe. And as it shrinks with dryness, it'll actually shrink away from that pipe because clay wants to hold its mass. So that pipe would last better bare in the soil than wrapped in filter fabric. Certainly the sock would be terrible and the burrito would clog up faster. My problem with direct burying a pipe in clay soil is that I have very limited surface area here to collect water. Water doesn't run through clay very well, so you want to maximize the surface area that's permeable so that more water can get to the pipe. And that's where this solution works really well. How does it work? Well, predominantly this trench is taking water that's coming up. When the system is in equilibrium, water between trenches, the water table between trenches will arch like this. Higher water table, lower water table. Most of the water is coming in through the bottom, and it's just the nature of how gravity works that as the water pushes up from the bottom, it's going to drop a lot of its fines toward the bottom of this trench, and only the water will make it to the pipe. Some very fine stuff will make it in the pipe, but that's going to wash down the pipe, assuming you don't have any low spots in the pipe where it would collect. So predominantly the trench is taking water from underneath. Now during rain events, when you have more percolation down through the surface, which is also a problem in clay soil, percolation isn't very good, you're going to get some in the sides. But that's okay because you have the gravel buffer to contain the fines before they get to the pipe. But what's going to happen, because every system has a service life, is gradually fines are going to start to accumulate where the water's coming in on the side of the trench. And so over a period of decades, gradually this is going to incorporate. That's fine. I'm not designing a system to last 200 years. This is going to last a very long time. The purpose of the fabric on top is not to filter water because it's going to clog up. It's clay soil. The purpose of the fabric on top is to separate the backfill material from the stone to keep the stone clean only until this backfill reconsolidates, as clay does, into a single kind of mass, a smeary mass, not a crumbly mass. So I want to keep it while it's crumbly from infiltrating the stone. Once it reconsolidates, as Mother Nature settles it in and it gets rained on, it's really not a problem. I could have used builder's paper here, and that would have been fine. Something that just stays integral until the soil reconsolidates itself, because you're not going to get a lot of water flow down through this over time because it's clay. It's going to percolate slowly, which leads me to the last important thing. After I finish this subdrainage project, I'm going to have to make sure that I scarify the surface on a routine basis every year, and then I grade out so that it's got some sort of continuous slope to help it drain right after rain events, because the water takes a while to percolate into the ground. A few other considerations that I've run into, heard about, learned of, wanted to convey. The corrugated pipe that I'm using is actually better than Schedule 40 or Schedule 80 PVC in frost-prone ground such as I'm digging in. My subdrains are going to range between 2 and 3 feet deep, and so they're going to freeze occasionally in the wintertime. The ground's going to freeze. The water in the drain shouldn't freeze because it should be, if I slope it correctly, continuously flowing. The reason you don't want to use Schedule 40 or Schedule 80 PVC pipe in frost-prone areas is because the ground moves when it freezes, it heaves. Schedule 40 and Schedule 80 pipe are not flexible, so they'll break instead of flexing. Corrugated pipe flexes. In addition, unlike Schedule 40 or Schedule 80 PVC pipe, which has holes just on 2 sides that you face toward the bottom of the pipe when you lay it, corrugated pipe has drainage holes all the way around it. So it makes the system more robust in the case of future siltation, because the pipe can drain all around, no matter if there's silt on one side or not, it can drain. Next thing, why not just fill the entire trench with stone, bring stone to the surface, and then you take care of surface drainage as well as subdrainage? And that wouldn't work very well in my condition. First of all, it's really expensive. Stone is very pricey. I know that. I just wrote a check for it. But in this case, in the winter pasture, you've got exposed dirt. The cows pug it up, you're going to have exposed soil, and if you grade that to drain, you're going to have clay that gets picked up with surface runoff during a rain event. And the clay is going to make its way into that stone on top of the drain, and you're going to wind up with a clogged drain. A few other alternative systems that may come to people's minds: putting gutters on the barn. I'm not doing that. In snow country like this, it can be done, but it's a lot of complication and a lot of maintenance, a lot of climbing up there and cleaning gutters. I'm not interested in do that when I get older. I don't want gutters on the barn. A relation to that is capturing the rainwater from the barn roof and using it to water the cows. Again, lots of complication. You've got to maintain a tank, probably a pump. You've got to make sure the water's clean. You may have to test the water for pathogens. Well water is cheap, abundant, and easy here. It's much less complication than trying to store and use water. We're blessed with a lot of water resource here in the Northeast. The other thing that may come to people's minds is using surface drainage, just running swales to drain the surface water. Well, that's not really going to drain, unless they're very deep swales, very well. And the problem is that I'm running haymaking equipment over one portion of the system, and I'm running cattle over the other portion. Cattle don't do very well with uneven ground, and what they tend to do actually is get in there and try and flatten it out. They'll push it around. I have a hill in the winter pasture made last year that they've almost all flattened out all the way. So ditching and swaling doesn't work very well. To finish out this video, I want to show you some of the materials I'll be using. This is filter fabric. It's different than geotextile fabric, and I've cut this to a 2-foot width. With the chainsaw, which melted it a little bit, but otherwise worked great, you'll see it's a non-directional woven fabric. And it's thin enough where you can see my hand through it sort of in the sunlight, but it's specialized for drainage, not just geotextile structural fabric, which is in a grid weave. And finally, here's my stone ready to go. I had 80 tons delivered a couple days ago. When it comes to rounds like this, size is denoted by number, with the bigger number, the bigger size. This is a mixture of 1s, little guys, and 2s, the bigger guys. It's been run through a screen. It hasn't been washed, but it has very few fines in it. This is going to be what I'm putting in all my trenches. And that's it. It's still early, so I want to get back to digging. I want to leave you with one other thought. When I was an architect, and this is probably common to a lot of architects, I wasn't a big fan of building codes. And the reason was because building codes are an attempt to create a one-size-fits-all solution to a lot of different circumstances. And so some people, well-meaning, have codified certain ways to do drainage. It doesn't apply to me because I'm on a farm. I'm under ag and markets here and not under local building code. But if a code says to always install subdrainage using a specific type of pipe with a specific type of arrangement of filter fabric and stone, they're missing out on a whole lot of situations that you're going to run into, and that could be prone to failure. The important thing is to think through how the whole system works given the type of soil that you're in, and then come up with a solution for it. And maybe, if you're doing it over and over again, improve that solution over time. I hope you found this video informative. Have a great Sunday, and I'll see you next time.